My name is Eric Cavanaugh. I will be your host for today's web seminar. And folks, we're getting way into the world of real-time analytics, streaming analytics. This is really good stuff, folks. The topic is ahead of the stream, how to future-proof real-time analytics. That's what we're talking about. And here we go. So there's a slide about yours truly and enough about me. All right, so the mission, as many of you know, is to reveal the essential characteristics of enterprise software. We do that by hosting live analyst briefings before a virtual studio audience. That's you out there, folks, and your job is to ask some good questions. Now let's talk about these different tools that are out there. We're talking about streaming. Of course, Apache Storm, no pun intended, is very hot these days. Spark is everywhere. Spark is the hottest Apache project at the moment if you gauge it by the number of developers or number of committers that are involved. And there's more innovation coming. This is something that Dr. Bloor pointed out probably 6 or 8 months ago. The innovation wave is not over. Well, you can imagine if you're a CIO or CTO or even a CEO in some large company, you're looking at this innovation wave and wondering, well, how can I prepare for this? How can I make sure that I don't make the wrong bet and wind up having some serious trouble down the road? So that's the concept we're talking about, is future-proofing. And the vendor in the hot seat today, if you will, is going to talk about their layer of abstraction they've designed to enable companies to future-proof. I will point out there's always some latency when you have a layer of abstraction, but that stuff is everywhere these days. Virtualization introduces a layer of abstraction and thus a slight latency. But I think what you're going to learn is these folks are pretty smart and they designed an architecture that handles that quite ably. So Robin Bloor is the analyst today on our show. Very pleased to have him in the briefing room. He's actually been hard at work on a book about the algebra of data. Yes, indeed. Watch for that, folks, very shortly. We'll do a webcast early next month that explains what this thing is all about and why you should pay attention. It's a pretty big deal, folks. So Impetus, founded in 1991, Impetus offers a variety of products and services across the big data ecosystem. Just today, as a matter of fact, they launched StreamAnalytix. It's an open source real-time streaming capability for big data. This is really interesting stuff. So it lets you use multiple Apache components. We've heard about Yarn, yet another resource negotiator, Spark, Storm, and even Kafka coming to us from our friends at LinkedIn. I love that name. They're very profound. So we're going to hear from Anand. He is the product head at StreamAnalytix and Impetus Technologies. He's been working with Fortune 1000 enterprises to deliver real business benefits and ROI from big data solutions over there at Impetus. We're very pleased to have him online. He's been busy since they had the launch today, so we're pleased to have his attention. And with that, I'm going to hand the keys over to you, Anand, and you can take it away. So the floor is yours. Go ahead and share your screen and show us what you got.
Thank you. Thank you very much. Pleasure to be with the audience today, whether you're live or you're recording or you're listening to a recording. I'm just going to quickly share my desktop here so that I can have random access. Is it visible, Eric?
Yes, indeed. Looks good.
Okay, great. So thank you all. And this is a presentation about StreamAnalytix, a real-time streaming analytics platform produced and offered by Impetus Technologies. Very quick introduction to Impetus. We were founded in '91, but here in the U.S. Operating since '96. A lot of global companies that all of you would recognize are our big data clients. We've been working with them as a big data solutions and integrator company that has been putting together big data solutions in a services mode from the past 5 years or so. And in that course, we have learned a number of valuable lessons that has obviously helped us to build IP where we see gaps in the ecosystem. So we caught on to the real-time streaming analytics bandwagon quite early after doing a few implementations for manufacturing and telecom customers. And the result of all of that work is this product called StreamAnalytix. I'm going to tell you a little bit more about that today. But Impetus, we have 1,600 people based in Los Gatos, the headquarters where I'm based, and we have a number of centers in India as well. So coming to you, the audience, you're probably here because there is an interest in your mind about real-time streaming analytics. And the questions in your mind that potentially are revolving around are like, why should I care? Is it really necessary? What is the compelling value proposition? And if so, do I buy something? Do I build it myself? If I need to buy, what shall I buy? From whom to buy? How do I integrate it? The number of those questions are very obvious and natural. And the topics here that I want to just go through quickly are tuned to address some of those questions, right? So quickly, the business needs some quick view of the industry verticals and use cases that we are seeing, a view in the architecture, and then getting deeper into the StreamAnalytix approach itself. And I'll tell you a little bit more about that announcement. And just to clarify what the launch was about today, it's actually we launched this product and it was GA in February earlier this year. But today we launched a free version, a couple of few free versions of this product. So I'll tell you more about that later. So why streaming analytics, right? One of the simple answers is because it's possible now. The technology has evolved where companies can now afford to have high-power computing, high-performance computing, clustered computing, very, very, rapid and large-scale computing available to them at lower cost. So why would you not use it? And, people are very quickly realizing that batch is old, and doing batch processing once in a few days or once in many, many hours, people are not contented with that. Enterprises really want to get more real-time visibility into their business and take more timely decisions. Specifically more, if you go deeper into why, I think there are two broad areas that in terms of use case categories. One is customer experience, to anything and everything to do with enhancing and making the customer experience much more real and context sensitive. Two is operational intelligence. So everything that is not to do with customers, it has to do with increasing the operational efficiency, tracking systems, bringing down costs of how things operate, doing things the most effective and efficient way. So that would be overall the bucket of operational intelligence. So a common problem, a common desire we see now is, speed up batch processes. Rather than, having that banking customer, having that customer walk into a bank and tell you that, my income went up, or, I just got a few million in the bank, right, just because I was working for a startup. Any such information that the customer volunteers or provides, if the enterprise is not able to process that immediately, and if there goes into a long ETL job and another analytics job and a reporting job, all of that would take days and weeks for that to react and respond to that customer with the right offer. That customer is gone. He's already buying something from some other source. So bridging this gap of days and weeks between the sensing and analyzing and acting and taking that down into the domain of seconds and milliseconds is the whole power of streaming analytics. And, coming to you and me, we're engaging with these enterprises of the banks, telcos, retail customers, retail, enterprises, et cetera, on all the channels, right? Mobile, web, on the IVR, social media. What if all of those interactions could be really, gathered together, correlated, and let's say when you call the call center, they knew who you are and they knew what you did just a few minutes ago so that they could provide you context-sensitive service. And that would obviously help us as consumers to make better decisions, to not waste time shopping around. And of course, there's a border of privacy that they've got to maintain. So there's a delicate balance to be maintained there. But overall, context-sensitive service results in happy customers, loyal customers, revenue, profits, and growth. So quickly getting into specifics of what kind of use cases are being seen today, I'm kind of breaking that up into, there's some text here that I'm hoping that you can all see well. So let me just go back up. Verticals, right? So there are some vertical-specific use cases that we're seeing. Predictive maintenance is a big one in the manufacturing sector and oil and gas. Whenever there's expensive, high-scale, high-cost equipment manufacturing something, you want to know before it breaks down or even if it is tending towards a breakdown situation. So historical analytics with machine learning and being able to predict a failure based on historical data or anomalies would be predictive maintenance. We are seeing clinical care and patient management type healthcare use cases. Sensor analytics is something we see in oil and gas, where or even manufacturing, where temperature, pressure, and a number of other sensors are constantly being analyzed to make the best decisions in terms of machine control, as well as, again, like I said, predictive maintenance. Fleet operations, people looking, analyzing whether that driver is shifting gears too fast or applying the brakes too often, and then finding the most optimal route based on even real-time data. Fraud and anomaly detection we see in the financial services industry as well as other industries. Gaming is a great real-time use case where you analyze the progress of the large gaming community and actually alter the game and make it more difficult, throw more incentives in, things like that to adjust to the player. Churn analytics is something that is very, very important for telcos or other large enterprises like that. They want to know if you and I are going to leave them or going to stay with them, right? So it's for example, a large telco that we've known obviously wants to know whether when you call in, whether your two-year wireless contract is coming up for renewal, or did you just renew? And based on that, the treatment is going to be different. And because if you are coming up on a renewal, then your mood and sentiment is very, very valuable to them because they don't want you to leave. They don't want the renewal and not for you to churn out to another player. So that whole context there is a piece of real-time information, and everything you did, your sentiment, how you're doing, did you complain or were you happy? Every one of those little data points that you communicate is an important thing for the telco to analyze and give you customer service accordingly. So other cases are network traffic analysis and optimization, where we see billions of events per day being analyzed. Internet advertising is a natural case for streaming analytics, where within 10, 20, 30 milliseconds or so, the system's going to decide what ad to put in front of your eyes when you show up on a website. There are some really cool use cases that we're seeing across verticals that are equally applicable, whether it's insurance or telecom or banking, or other verticals as well. Customer experience is always something that everybody cares about. Everybody is serving consumers. So some things that I just described, which is triangulating between the customer's location, the time, the most recent actions, all of that applies to pretty much every vertical. Clickstream analytics is somewhat a part of the customer experience. Context-sensitive offers and recommendations is, again, it's still in the customer experience, but specific application of that. IT log analytics, people hit us very often for Splunk replacement type use cases where they're really trying to stream a lot of data from servers and other infrastructure, and they need to analyze it and take actions. Security analytics is also naturally a real-time use case where you obviously don't want to take action tomorrow if your systems are being breached today. So again, analyzing those patterns, keeping those models running and trying to detect new threat patterns and catching them fast is obviously critical for saving and protecting economic value. And I've called a few areas as combos. They're kind of verticals on their own, but internal to them, they can serve a number of sub-verticals or across different verticals. The Internet of Things is something that we often hear of today. Anytime there are sensors or devices talking to each other, and that's obviously applicable to data center, to buildings, to homes. So again, those are the sub-verticals inside the IoT space, and that is an area ripe with real-time data and the potential for doing a variety of different real-time analytics. Anywhere there's a mobile phone and mobile apps, again, applies to across verticals, mobile app analytics. And another space that we've been running into quite often is call center monitoring and analytics. Again, every major company that's in front of consumers has call centers, and they all want to know, how the agents are doing, how can I route this particular customer to the most favorable agent, depending on what the customer wants, what's likely to want. Those kind of, and then of course agent performance, customer sentiment analysis, all of those things are top concerns of across industry verticals. So that's just a quick sweep of different verticals and use cases. I'm going to quickly get into build versus buy, and I realize there's so much content to cover here, so I'm going to move quickly over each of these items. So build versus buy, I think today we see that discussion, that question coming up pretty often. In today's world of where you have a lot of different options, if you want to build on your own, build a platform on your own, number one, you've got to decide what business you're in, right? If you are in the banking space, if you're in the telecom space, you might want to reserve your resources for your core business logic and your application. If you end up spending all of that energy and time building out a platform infrastructure that is easily buyable or that is already available in open source, then you should have obviously very, very good reasons why you want to do that. So it requires a huge commitment of time, skills, and budget to build out these sophisticated platforms and to maintain them in the long term. For some reasons, some people might prefer to do that because they want that leverage, they want that control to determine their destiny. And if you have that kind of resource, that's good. Gives you the maximum level of flexibility and control. But it also takes away a certain amount of time. So if there is a senior vice president looking down your shoulder and asking you to demonstrate a use case or show a POC really quickly, which happened with some of our customers, you may not be able to turn that around very quickly if you're in build mode. But that's said and done. That said, it may be just the wise choice that you have to make. It might be the wisest choice for you based on your circumstances. But let's look at the buy side. You would obviously buy if there are ready-made options available that meet your needs. And the questions would be, what are the selection criteria? So we have actually written a paper that's called 10 Considerations for Streaming Analytics. So that's something that we can make available for the audience. Let me get into the architectural considerations, right? So we talked about real-time analytics and historical data. So the best thing would be to get a blended view of historical information and real-time. And most of you all have heard of Hadoop and probably have projects underway to implement Hadoop. If not in an enterprise data warehouse, then Hadoop and enterprise data warehouses obviously work great on the historical side. Of course, Hadoop is now a platform for putting any kind of workload, which is why you have Storm and Spark kind of workloads on the Hadoop platform. But the focus here is that the small window on the right side, which is the real-time analytics. So a blended view of both historical and the most recent information is probably the best blend of information that you need for decision making. And an architecture that brings that together is what's called the Lambda architecture. You probably are familiar with. This Nathan Mars actually wrote a paper on this and was the originator of this thought process. There's obviously more sophistication now around this, but the whole idea here is, batch is what exists in enterprises. There's a nice, well-defined batch workflow, likely pretty much in every enterprise today, where there's batches of data coming in, being processed, being analyzed on a daily, hourly, weekly basis. And then there's a whole analytics stack and a BI stack that business users would use. What we're seeing happening now is the data coming in and splitting up right in the front as incoming speed into the speed layer, a parallel feed into the speed layer while it also goes into the batch layer. And the speed layer computes that recent information that you need in terms of just what happened in the last few seconds because the batch layer will not be able to produce all of those insights in the amount of time that you have. So the batch layer would continue to compute historical insights, historical analytics, and you blend both of that to get the best decision. And going forward, what is likely to happen and what is happening we're seeing is there's going to be only one entry point instead of two here, and that's going to be not the batch, not both, but probably the speed layer itself. So picture that all data will come in through the speed layer, will get dynamically, assessed, pre-processed, filtered, and get ready for analytics and land into a place where it is ready for analytics in terms of its format, in terms of data quality, all of that. So that is the huge advantage that the speed layer provides, and that's, again, something that we have also incorporated into StreamAnalytix. All of this is possible with StreamAnalytix. one may wonder, how do we, once I have all of this, how do I integrate it with the rest of my enterprise architecture, right? So all the data types on the left side, landing straight into a landing and ingestion zone, and your conventional RDBMS data, EDW, and MPP data warehouses are right there. And there's a feed into that, and there's a feed into Hadoop as well for the data lake. And there's a parallel feed into the real-time layer where all of your real-time analytics are performed, and obviously there's context enrichment, and there's data going from the historical side into the real-time layer for enriching some of those decisions. And so you can see here everything feeds into everything in some ways, and finally, when on the data access side, you're also getting feeds from both the real-time and the enterprise data lake. And not to forget about the most critical pieces in the system in the bottom, which is extending your age-old robust governance and compliance and security information lifecycle, metadata management. All of that needs to be extended now into the new world of both the data lake as well as on the streaming side. So we've taken into account that large enterprises, which are in some cases regulated, would obviously have all of those constraints. So we're building out all of that into our architecture, into our systems that we build for customers on a services basis, as well as the products that we build. Coming to your options today for streaming analytics, you have proprietary platforms on the left side, which is enterprise products that have been offered by IBM and the TIPCOs and software AGs of the world that are fairly well known. There's obviously a number of those robust, good products that you can choose from. The disadvantage is you're not leveraging the vibrant open source ecosystem. You're still subject to vendor lock, and it could be a pretty high-cost solution compared to using open source. And obviously, you're limited to the flexibility that the vendor provides you and the innovation speed of the vendor. On the other side, you have do-it-yourself as an option, which is, okay, well, I'm going to go and, thanks to the democratic access of open source, I'm going to download it and build it myself. Again, like we said before, that has its own implications, right? There is a significant burden of integration and maintenance that you have to go through. You have to have a team that's pretty well versed in the technology, integrating it, tuning it for performance and ongoing maintenance. So there could be significant delays to market, in time to market, as well as ongoing costs. So each of these have their disadvantages and issues. So that's the reason why we decided to blend both of those options and take the benefits of both of those options and get rid of the disadvantages of each of those and create a third option called StreamAnalytix in the case of streaming, which provides you an enterprise class reliability, manageability, UI, the bells and whistles that enterprises need to really count on these systems to be mission critical, and still not compromising on the advantage that open source provides you in terms of you have access to the constant innovation, you have access to a lower cost, in terms of capital investment, and there's community innovation. You have literally access to a worldwide community contributing and innovating all the time. So a great combination of the two would be if you have enterprise class systems built on top of these open source and offered to you, and that's what StreamAnalytix is. So it's an abstraction of functional components, ingestion, complex event processing, analytics, visualization, all of the required pieces that one needs to build out streaming analytics applications under one platform. There's also another type of abstraction we're doing, and this is where it gets into the whole future-proof aspect here, which is today the system is based on Storm. I'm not sure if you can view all of these, the lines in this. There's three radial lines going from that StreamAnalytix, a circle to each of these three blocks underneath. So today you have Storm. We have Spark streaming support coming up later this year, and we're building an architecture that enables us to bring in any streaming engine similar to Spark streaming. So it could be Apache Flink, it could be Heron, it could be any number of different innovative new open source systems that could be brought in eventually, and that's with the inclusion of just even the second technology option, which is Spark streaming. What we're doing is we're building an abstraction layer which is to eliminate the concern of latency. The abstraction layer really does not produce any latency in the operational side. It is an abstraction layer from application definition to operationalizing on the engine. There may be some things very, very minor in terms of data format changes. For example, we transpose every data that is incoming into Storm today in StreamAnalytix into JSON and make that available to the app. That's only a huge advantage for the system. So there may be very, very minor latency issues to consider, but still it's in the range of 20, 30. We have produced end-to-end results in 20 to 30 milliseconds, or in many cases. So if you can get 20 millisecond response times for a real-time use case, I think that we've not really seen any use case here in general that has challenged that benchmark. But the point here is you have a future-proof option. Today start with Storm, tomorrow add Spark streaming, and then you don't need to worry with this abstraction layer. You don't need to worry about how the technology ecosystem is flowing. How we get that done is using this kind of architecture diagram, architecture approach, where we have the underlying streaming engine, of course, right in the center. It could be obviously deployed on top of Yarn or on independent hardware and virtual machines. We have our platform riding on top of that, providing you the application development interface. And so you can wire together using UI, drag and drop components, and wire together your workflow and submit your workflow into Storm or submit your workflow into Spark. We obviously have we have done a lot of research and work on this. It's not obviously possible to have 100% abstraction. There would be some things that are special to Spark streaming. There is something special to Apache Storm. So you would, at this point, the first approach we're taking is you would, at design time, you would choose what streaming engine you want, build that, and build a workflow. The workflow definition does not have any, technology-specific semantics. So in Storm, you have bolts and spouts. In Spark, you have RDDs, etc. So we don't have that kind of semantics at the application definition layer, so that you're free of the engine in terms of defining the application and then pushing that workflow into the operational streaming engine for that to execute. So it's going to be a very, very powerful, one-of-a-kind. There's no such option today in the industry that enables you to work with multiple options. Today it is Storm. Spark streaming is coming later, but that's what we call the future-proof option, where we have unified business interfaces, common utilities, and kind of smart workflows that enable you to receive data from the queuing side on the Kafka, RabbitMQ, etc., process them in the streaming engine, and write them into a data store such as Hadoop or NoSQL, or indexing such as Solr and Elasticsearch. And naturally, there's a Hadoop platform underneath, which could be any one of the distributions, any one of the three major distributions. We are compatible with all of them. And there's UI. So, for example, you would define your metadata using screens like this, where you tell the system what is the data, what kind of data format it is, determine all the fields, configure your alerts, and then here's an example of a screen where you would, literally choose channels, processor, and emitters, where you drag and drop your sources, you drag and drop one of your different operators here, so complex event processing, custom, filter. So you literally drag and drop each of these, draw lines, right-click, configure, and then once you're configured, this whole workflow is ready to be submitted. You submit it, and it's ready to go. So it's that easy in terms of just we're making it really, really quickly possible to build an application within minutes and submit it to, let's say, Apache Storm and watch it functioning. And the beautiful thing about this is, if you're looking to submit your own, custom code and custom logic, here's an example of a screenshot that actually helps you to do that too. So you don't need to write anything specific to Storm. You can just write generic Java code, and we will convert it into a Storm bolt in the case of Storm, and similarly in the case of Spark as well. So you can submit custom logic and connect these workflows to other applications as well. And not only do we support the application development cycle, we also do the application, the operations cycle as well, which is the monitoring part of the cycle. So we are very keen on supporting the ops person and ensuring that the ops person has full visibility into the application. So if you want to monitor the throughput or the latency of your entire workflow and raise alerts and be informed and then go in and assign more hardware, et cetera, to certain pieces, we have that facility. We have a real-time dashboard example here. Also, this is also part of the product, user management, et cetera. So one last thing before I just pause and see if I have time for a couple of case studies is whom to buy from. There are, of course, small startups, very large companies. The small startups, the problem is you don't know whether they're going to exist or not. They're going to get bought out. And the very, very large companies, you don't have enough leverage with them. So Impetus tends to be a nice sweet spot in the middle where we are right size with 1,600 people. We have stability as a 20-year-old organization. We provide services around the product. If you need, there are customers of ours that have taken the platform and built out everything on their own. There are customers of ours that have said, hey, why don't you come and help us? So the services aspect, I think, is we have seen as something that customers really appreciate because they're able to take their use case into production very quickly. I'll take one, maybe 2 more minutes and go through a quick couple of case studies here. Here's a call center solution where this customer is obviously having a distributed infrastructure, and they wanted to get visibility of what's happening on a particular call when an agent picked up the phone and when the customer was put in a queue and then transferred from one place to another. What happened to this customer? How did that call progress? And they were having a really hard time trying to pull together data from across these different boxes across the internet and analyzing what exactly happened. They said, hey, can you do this for us? Can you stitch something? Can you take pieces of call logs from various servers and stitch up a real-time view of a call so that when a customer service call comes in, we know what happened on that particular call. So we built this kind of visualization where we're injecting records from across servers, media servers, IVRs, across the internet, and stitching up a call. This is a view of a single call where, dialing and then 0.08 seconds went to ringing. It was answered at a particular time, and the call was moved to the IVR. The outgoing call leg happened at this particular time, et cetera. So this enables this hosted call center company to put some filters on the top left, zoom into on that particular day from that location to this location and from 7 to 9 p.m. what happened and which calls were there. So they zoom in and they're able to take good decisions on and do debugging and also doing customer service. Here's another view of dominant IVR path analysis of how many customers are on which particular IVR path, so they can tune the IVR options and provide much more tuned customer service, based on the traffic and what options customers are viewing. Another visualization there. There's a large telco that we're working with. Also, they're ingesting set-top box data. They're looking at maintenance tickets, and they're also viewing customer engagement in real time. So, based on which channel, they can choose a channel and see what kind of customers are viewing it. They can choose a customer demographic and say, okay, what are young people between the age of 25 and 35, what are they watching and when? So they can put in all these filters and actually see how customers are engaged, what are different customers doing in what part of the country. And all of this happens in real time. So if your set-top box is misbehaving, they want to see a national view of where the errors are coming from, and in terms of omni-channel, which channel is being used by customers, estimating the customer's sentiment or potential frustration score, because if your DVR set-top box is throwing up errors and you have opened up a maintenance ticket and you call into a call center, that means you must be a fairly annoyed customer. So we're predicting all of that in real time, telling the call center person that this is the history of this particular individual, and their potential frustration score is, on a score of 1 to 10, it's probably 8 or 6, whatever it is. So that's a quick view of a real couple of case studies that we have done for some customers. And this is a national view of the chat dashboard, how many agents are how are they performing, who is the top 5 agents, things like that. Before I close, here's the view of the web page where we are offering a free version of StreamAnalytix for our audience and for the global audience. There's 3 versions, Lite, Developer, and Enterprise trials. So please go to streamanalytix.com/download. You'll see all of this. I'll stop there and hand it back to Eric.
All righty. I'll take back the keys very quickly and jump out to Robin's deck. We got a couple good questions already from the audience. And I know Robin's going to have some questions once he gets rolling. And there's your first slide. And Robin, take it away.
Okay, thanks for that, Eric. Really, I think there are some things happening here that are kind of new in the sense that, we've looked at the whole of the data lake environment and analytics, and streaming analytics in one way or another has seemed to be, if you like, much more of a side event, and it seems to me that it's coming to the center in one way or another. So I thought I'd kind of go through, just there's a division here. Analytics and streaming analytics are absolutely not the same thing. I mean, apart from anything else, streaming analytics is pretty much the analytics of time series, because in one way or another, or events, because in one way or another, they come in a stream, and if you're going to have low latency response, you can't do a whole heap of much else when you're processing a stream. However, this is the analog that I've used ever since, ever since we first had the presentation on the briefing room about streaming systems. And the human control system is interesting in lots of ways because it works at different speeds. We have internal systems, digestion, breathing, heartbeat, and stuff like that, mainly under the control of the enteric nervous system. It looks after itself. And these are like the internal systems that exist within organizations, except nowadays they can go a lot faster than they did before. Then we have two different kinds of response to external events. There's an instant external reflex, which normally goes to the spinal cord, and it's normally extremely fast indeed. And then there's a fast external response, which is something like I throw you a ball and you catch it. You don't think about catching it. You just don't want to catch it. And that normally goes to the spinal cord as well. It normally doesn't meet the brain. You don't even think about it. You kind of realize you did it afterwards. And then there's a considered response of the brain. Swift external responses, pretty much in one way or another, they correspond to predictive analytics or to triggers. In one way or another, you can often respond, personally, extremely quickly to something that's a shock because your body seems to know what to do. If it meets a shock that it doesn't know what to do, it's as hopeless. Or you actually have to think your way through it, in which case you're probably too late. And the considered response is analytics. Well, when we looked at this like 2 years ago, the way that I was trying to accommodate this is in this diagram here. I know it looks a little bit complicated, but by and large it's not. We have the idea right in the middle there of a filtering and replicating and routing capability, which sends the same data in both directions, but the streaming data is just hived off, and it goes in one way or another through systems that need a fairly instant response. And then the idea of just dropping the data into the data reservoir. Well, that was a very credible architecture a couple of years ago. It's starting to be less and less credible, and that's really because of the emergence of the Lambda architectures, which have already been mentioned. So there's something for us to talk about in that alone. So, the Hadoop disruption was not just that Hadoop came in with a highly scale-out file system, but it turns out that you could do pretty much everything on it. And then the last time I drew this diagram, I had to add real-time analytics, basically because of Storm at the time. But, now that Spark has become the flavor of the month, or perhaps the flavor of the year, there's an awful lot of talk about Spark doing real-time analytics. So I kind of thought that I would say a few things about that. Really, Spark, in my opinion, it became very, very popular because it had an in-memory scale-out capability. And what had happened really was that MapReduce had become, you know, the only club you could play golf with. And then Spark comes along. MapReduce turns out to be horribly constrained in a lot of ways. Spark turns out to be a very good replacement for it. And in 2013, it's kind of a while ago now, with the release of Hadoop 2.0, you got Yarn and you had the capability of having something for anything to bolt to in actual fact, but they unbolted MapReduce and in came Spark. And it became so popular so fast that I almost, I was kind of, you know, I was shocked by it, you know. And Spark can do streaming to a degree, but it's not ideal, and it wasn't actually written for streaming. And then there's certain kinds of very low latency applications where you wouldn't scale out unless you had to, where you're actually wanting not even to hit the network. You know, I mean, and they are few and far between, it has to be said, you know, but they do exist. And Spark was never written for anything like that, but it definitely has its place, is what I'm saying. And then we come to this Spark versus Storm. Spark, I kind of thought it was worth mentioning here that there's Shark, although I believe it's now called Spark SQL, which sits over Hive. So in one way or another, Spark has become, I would say, that there seems to be so many people working on Spark to provide interfaces to anything it doesn't already have interfaces. But it looks incredibly fully formed, so to speak. Storm provides batch and streaming, but it is an event processing capability. And it used a Lambda architecture, I think, from the get-go in order to do that. And Anand's explained that very well. There's no need for me to say anything more other than that the Lambda architecture splits up the batch activity from the streaming activity. And you end up with a batch layer and a serving layer and a speed layer. And in one way or another, you have to make that work to the latency you want. So Spark now is a Lambda architecture, and it can behave in a similar manner. And it currently seems to be more fashionable simply because of so much attention in the press and so many people seem to be working on it. And my current view now is that streaming is more about data software architecture than it is about anything else. And that's all I've got to say, really. I actually wanted to, I really thought probably the best thing to talk about, and ahead of anything else, is that clearly my understanding, and you can correct me if I'm wrong, but my understanding is that you implement a Lambda architecture yourselves, and then you can push that down into Storm, and you will, if I understood the slide correctly, you'll be supporting Spark fairly soon. There's obviously an issue with a Lambda architecture, and I thought I'd like you to speak to this, which is just that you normally, if you're doing streaming, you normally have a latency target that you want to meet. So there's a need in one way or another to ensure that you're meeting that latency target. And because of that, there needs to be a balancing of the workloads. Would you like to speak as to how your technology addresses it? And then after that, speak as to how it addresses it when it pushes stuff down into Storm.
Sure. Thank you. Robin, yeah, I mean, you know, the Lambda architecture is obviously powerful. It is a pattern, I would say, that can be implemented with different technologies. And in our case, typically people have used Storm as the speed layer. And the way we implement interaction with the batch layers, we've built adapters that can read and write to Hadoop or a distributed cache or maybe edge-based and an index, right? So we actually have readers and writers into the historical data stores. So thereby we can interact, and with, for example, in our system, we pre-provide a distributed cache, in this case, you know, by default couch-based. So you can cache data in that layer. So we have access to, in memory systems, we have access to caches, we have access to HBase, and we have access to indexes, and we have access to the incoming stream that can be processed in memory. So pretty much with the applications that you can build, you can do all of this and essentially implement the Lambda, right? So that's the way we do it. But it's all running, the computing and the data read and write and the blending is all, of course, happening in memory here, even in Storm. So you provide that, you're able to do that latency unless you actually have you're depending on a disk I/O, which will, of course, kill latency anyway. So that's a quick view of how we do the Lambda today, and it has proven pretty powerful in that telco use case, for example, also that we're getting set-top box data live, and we're also dipping into a database to see maintenance tickets or customer profile information, quickly blending those two together in a few milliseconds, and then providing the call center agent with some information.
Yeah, that's pretty low latency, isn't it? In terms of, I mean, you obviously took the choice to implement on Storm before Spark, and if you'd asked me a while ago, I'd have said, well, yes. That would be the logical thing to do. But Spark's next in line as far as you guys are concerned. Do you see Spark as actually kicking Storm out of the, as actually kicking it into the corner, or do you just see Spark as never being able to get to do the kinds of things that Storm can do? I mean, I think this is a reasonable question for a lot of the audience to have a learned answer to.
Oh, absolutely. I think Spark is extremely powerful. That's the reason why it has gained so much popularity, right? There's a nuance we're talking about here. So Spark is a micro-batch paradigm, and Storm is coming in from an event-based paradigm, right, as you have rightly mentioned, Robin. And they have tuned in, Spark streaming is essentially shrinking the batch window to such a small window, like maybe half a second, where you can collect batches of half a second and then do analytics on each of those batches, and hence you have near real-time data. And for many applications, that's perfectly fine, except in cases, let's say, for example, in an advertising technology scenario where you literally have to turn around a decision, a cookie comes in, and within 30 or 40 milliseconds, or even 100 milliseconds, turn it around and score the cookie, tell the system what is the next offer, whether I want to respond to this particular customer or not, and if I need to respond, what should be the ad or the offer that I want to position. All of that needs to be done within a 100 millisecond time frame, and that's not possible today with Spark, because it's not optimized for anything less than 500 milliseconds. Eventually, it might, because it's simply because of it is a batch paradigm being shrunk in terms of the batch window. But that said, like you mentioned, there are a lot of business use cases today which are perfectly fine, that don't need that low latency. But there are some banks that we're talking to, for example, that want to build out an infrastructure, one infrastructure that can handle both low latency use cases as well as the more lenient, higher latency use cases. If you're looking for one streaming engine that does both extremely low latency and near real-time micro-batch type use cases, it unfortunately cannot be Spark. It's got to be a pure streaming paradigm like Storm. And what I've heard, I'm not an expert on Flink, but what I've also heard is that Flink by nature is a streaming engine which is capable of doing something similar to Storm, and it does a few things that are not able to, that Spark's not able to do. So they're keeping our eye out on that as well.
Okay, well, I'm kind of run out of time, but I'll just ask one more question. In the diagram next to Storm and Spark, you actually had a box with the word next in it. Is there anything that you feel like that from the direction of supporting other, particular software components where you're likely to go next?
We have received a few requests for considering Flink, Apache Flink.
All right.
We are also tracking Twitter and what they're doing with Heron, which is the next generation of Storm in their infrastructure. So we're keeping an eye out on all of those developments so that we can fulfill the promise that we have made, which is the latest and greatest and technology which is truly enterprise ready and superior, which will incorporate into our platform.
Okay, in which case I shall hand you on to Eric and the audience. Eric, take it away.
All righty. So we have a couple good questions here. One just came in a second ago. Maybe Anand, if you can comment on this, or Robin, if you have some thoughts. The attendee is asking if someone can talk about the Kappa architecture, which is the next step after Lambda and used in the Google Cloud Platform data flow. I'll throw it to Anand first.
No, I haven't tracked the Kappa architecture, but I can tell you that we have clearly found that there's the Lambda as it is obviously defined today, which is a speed layer and batch layer, is not complete in that there is a rich interaction between the speed layer and the batch layer that is absolutely essential. In some cases, for example, we have a historical model that keeps getting evolved, and ongoingly you've got to keep enriching the model in that you're using to score in real time. That's an interactivity between the batch and the real time model, which is obviously an enhancement on Lambda. I would not be in a position to comment specifically about the Kappa architecture. We can, of course, take that question and get back to folks.
Okay, good. And I threw up this slide here because I like it. It gives a decent view of kind of where you're trying to go with this. Can you talk about what are the challenges in being able to deliver on this? Like as you were developing the application or this abstraction layer, what challenges did you run into that maybe surprised you a bit?
In terms of giving a blended view.
Yeah, exactly.
So if you're dealing with maybe 4 million subscribers, 3 million subscribers, let's say, or 5 million subscribers, and a call comes in, and you have to do a dip into a database and pick up the information and process it. So there's always a trade-off between the latency and the richness of information, right? So that is something that we have to constantly optimize and be careful about. So if you keep everything in memory, it's obviously great, but you have that will increase the cost of your system, which is you have all the data residing in memory. Versus if you do a dip, that's a latency issue. So that's definitely a trade-off, and it has to be solved depending on the use case and depending on what latency does this particular use case demand. That's one. And of course, there's visualizations that can be produced in both cases. And in fact, when you do both of that and succeed at giving the customer a nice view into what just happened versus also everything that this customer did, let's say in the last 1 month or so, it's not easy to produce a platform that does ready-made visualization without custom additions. So we end up doing some custom work to produce those fancy visualizations that customers want, and we have essentially produced a WebSocket interface to do that.
I see. Okay, that was actually my next question. You must have been reading my mind right there. So in terms of going and deploying at a customer site, someone, let's say a major retailer, has a need for this kind of solution. What is the development process like, or what is the implementation process, specifically in terms of how long it takes, and how do you connect to historical views? I mean, are you working just in this Hadoop environment, or do you actually connect to like an enterprise data warehouse or something? How does that work?
So yeah, I mean, we typically one of our, we find Hortonworks to be a platform that obviously currently works very ideally with our platform because it is Storm-based in terms of streaming analytics. So when we go into a system, and we go into an environment where they already are having a Hortonworks cluster, which is very often the case, they have data already there, and from that point on, the Hadoop cluster is already deployed. And in the case of this large telecom company, within 4 weeks, we were able to, with our platform and the underlying Hadoop cluster, we were able to produce all of those visualizations I showed you and the use cases. So literally within 6 weeks, 4 to 6 weeks range, we had about 6 to 8 use cases in different screens and visualizations up and running, and we're able to, show a very, very real scenario to the executive management, and that's how they made the decision to move forward with this investment.
That's great. And one of the attendees is asking about R, of course, which is becoming a very popular language for predictive analytics, asking, can StreamAnalytix integrate with R, both for content and for visual integration?
Yeah, we have done actually we have run our models directly on Storm, or the other way to do it is you build models with R, export to PMML, and we can import PMML into and score predictive models using using a Java implementation of the PMML libraries. We use JPMML, which is a library for implementing various predictive analytics algorithms, and that enables us to essentially pull any PMML model and score it, provided, of course, it is supported by JPMML libraries.
Okay, good. And here's a really good question, too. How easy would it be to migrate an application optimized for Storm over to Spark, and then the so-called next on the architectural slide? So, let's say you've actually deployed using Storm, rather. How easy can you actually migrate that, or is it kind of tied with the Rasa, you have to start over?
That is, anybody who is familiar with the space is obviously asking a very smart question. It is, if we have not done something extremely native to the particular streaming engine, it's very easy to migrate. And if we have used some specific features of the particular streaming engine, then there's got to be some work done to migrate it. But the whole point of this platform is to actually make that migration process much, much easier than it would have been without our platform.
Okay, I'll throw one last one over at you, folks, and then we'll call it a day. One of the attendees is asking, how different is this architecture from in-memory computing frameworks, so from traditional in-memory computing frameworks?
I would say it leverages in-memory processing because it's a distributed scale-out platform, but it also leverages. You can't have everything in memory, unfortunately. So it's a different architecture that leverages both disk and memory in some ways, where you can afford to, and it's not, and it has all the advantages of an in-memory-based system, because ultimately, whether it is Storm or Spark, the actual processing in real time is happening in memory.
Gotcha. Okay, folks, we burned through an hour here. Thank you so much for your time and attention.